Hello, and welcome to today's webinar, From Monitoring to Observability, How Approaches Evolved and What's Next. My name is Alex Berconi, and I'm part of the webinar team here at AppDynamics. Let's go over a few housekeeping items before we get started. First, I'm obligated to share a legal notice with you. So here it is, and then we'll continue on. Moving on, note that the console you are looking at is completely customizable. Feel free to explore the widgets at the bottom of your screen. You can also move or resize any of the windows you see open by dragging the bottom right corner. This will be useful as we go into the presentation. For the best viewing experience, we recommend closing any programs or browser sessions running in the background that could cause issues. Webinars are very bandwidth intensive, and closing these unnecessary browser tabs will help you conserve your bandwidth. If you have done these things and are still experiencing problems, whether it's with sound or the screen seems frozen, please refresh your browser, as that will usually fix them. If you continue to have issues, please reach out using the Q&A widget on the left side of your screen, and I'll try to help you out there. Speaking of the Q&A widget, we invite you to submit any questions you have during the webinar there. We'll answer as many as we can at the end of the presentation. Lastly, this webinar will be recorded and you'll receive a link to the recording by the end of the day. Please feel free to share it with your colleagues. And with that, I'll go ahead and hand it over to Erwan.
Hello everyone, very happy to be with all of you today. So we're going to do some history, look at how we do things in the past, how we are doing them today, and what the future could be. So in a nutshell, as we said, from monitoring to observability, how approaches evolved and what's next. So I'm a strong believer in that to understand where we are and where we're going, you need to have some ideas of what happened in the past. So first, once upon a time, as some say, applications were simple, kind of monolithic applications doing a set of capabilities running on a bare-bone physical server. And back then the approach was, well, if my server runs fine, then my application must run fine too. But as you well know, while the server seemed okay, the network, storage, compute, everything, you still had some issues surfaced by the customer. So there must have been a better way. So the round two, the idea was, well, even if the service is fine, maybe things get slow or hanged. So let's measure execution times. So roughly in the first phase, it was mostly about changing your application code and putting changes like start measuring here, stop measuring there, and report back the time it took. So I can know when things slow down or don't happen at all. But that was challenged by the approach back then, which was a trade of service-oriented architectures and virtualization. All of that increased the complexity, and continuously changing code to add, remove, tweak those measuring points was challenging. So then the approach was to say, okay, let's go with agents, which no longer require code change, and they can, once we deploy them, they can discover what is my application made of, where they execute, and to which other parts of the application they chat to. They discuss and exchange informations, do API calls, etc. So that was a big change, which is still valuable today, kind of. You have theoretical maps, architectures of your application, but we all know they grow big, complex. They change often, and having that reverse engineer real-time view of what your applications are made of, how they are structured, and how the information and processing flows between them is key. So that was a huge progress, but there were still challenges around root cause identification. So kind of, now I know how my application looks like. I know how it behaves. Kind of, it takes 1 second here, it takes 2 seconds there, it takes 100 milliseconds over there. And when things go wrong, I'm aware that something's wrong. It's slowed down and completely halted. But I still have so many things to explore to get an idea of where and why that happened. So to give you some examples, it was a few years ago. At a customer, there was a war room which lasted for quite some time, where application guys were pointing figures towards the database guys, kind of, your database replies to my request in 8 seconds. That's just way too slow. That's where the problem comes from. And the database guys are, well, when I look at my stuff, every incoming request is replying less than a millisecond. At the end of the day, the problem was that the application made 8,000 calls to that database. So if you multiply that 8 seconds, so that was a bug in the app. But without that high-level real-time map of all the parts, you couldn't see those looping calls that result in that taking too long due to the last change deployed. So DevOps was a rage, and companies started to deploy way more often, from few times a year up to many times a day. If you multiply that by the number of applications, the process was not the same. So many companies went from waterfall approaches, where I define everything and I do big bang releases once a year or once 18 months, to those agile loops where I deploy smaller changes in a highly iterative way, and I can validate, learn back, change again, and so on and so forth. So that DevOps movement took step in companies, and that drove adaptation of the monitoring approaches. One of them was, with DevOps came automation, especially around CI/CD, continuous integration, continuous deployment, and the need to shift more of that, to shift left more of those assessments. Kind of, it would be good if I knew earlier if my new drop would be slower, if my new drop would crash. And if it crashes or is slower, where and why kind of attitude. So that drove the need for more API, command line interface, to be able to automate some of that into the process, so that you no longer need a human staring at screens at 2 a.m., but all of that could happen more automatically. That DevOps movement drove the need, according to me, of what we saw as containers, so Docker won the war. That needs to have virtual server, easy, lightweight, that can be scaled up and down as needed, can be deployed in few command lines. And later down the road, the need to manage all those containers when there were too many. So that's what drove, for instance, Kubernetes, which won the war. And now we're talking about service meshes to make sure that they discuss with one another in a well understood and managed way. And that cloud movement, that infrastructure as code, whether we're discussing compute, storage, or network, drove the need to have, on the same pane of glass, both the application understanding, how it's made of, how it's behaving, but also what makes your application run. So my virtualized infrastructure, compute, storage, network, my supporting services, you can think of service queues, service mesh, etc., etc. And that's when distributed transaction tracing came to. So it dates back from 2007, 2008. And the idea is pretty simple, is whenever a transaction starts, whether machine to machine or human to machine, I give it a unique identifier. And then as it travels through my technology stacks, I can track it through all the hoops and bounds, thanks to that unique ID, and I can measure how long it takes to hit hoops, how it behaves, like error rates, transaction rates, and things like that. So why does that matter? With traditional approaches, when you get in the morning, you see you have 100 errors, for instance. So on the left, you can see 8% were errors, 12% were problems, and then each and every team will tackle their own. The database guy, the network guy, the application guy, etc., etc., the infra guy. As soon as you bring those end-to-end transaction traces into the picture, you get way more knowledge and context. So in that example, I just reordered the same things according to transactions, and now we can see that all of my transactions were impacted either by an error or a problem. And I can see the upstream and the downstream, who called me, who do I call, that guides and helps for full domain isolation. Where does the problem come from and why? And then further down, root cause analysis. So back to that transaction tracing, you might have heard, I guess, about OpenTelemetry, which is at rage nowadays. So it comes from two projects who merged together not that long ago, in May 2019, and the grandfather often referred to is Google Dapper. So the Google Dapper was transaction tracing done at Google back in the day, 2010, to trace and manage highly distributed and dynamic systems. AppDynamics, we've been doing that transaction tracing since our inception in 2007, 2008. So we've got a decent amount of experience in that space for thousands of customers around the globe across many industries in the most demanding situations. So let's talk about OpenTelemetry. So it's the new emerging standards, merging open census and open tracing. And the sole focus is about generating the data, generating the telemetry through APIs, SDKs, and some agents should come soon. So the idea is I generate the data, but I need a place to put it, and I need a place to make sense of it. So what does it cover? Super high level summary. Traces, what we discussed, the end-to-end transaction tracing. The V1.0 was out in Feb 2021. Metrics is supposed to reach 1.0 soon, you know, the CPU loads or any numerical value that repeats over time, and logs, which is in the scope but without clearly defined dates yet. So early days, maturing, we're not fully there yet. Now when we look about observability, so we discussed about DevOps, driving the need to automate deployments of smaller chunks, driving microservices, containers, and engines like Kubernetes. But observability also came from the need to kind of debug those highly distributed dynamic systems. So that's why I tend to call technical observability. So some oppose monitoring and observability, APM and observability, but to me you need both, depending on who you are within the company and your job at hand. So if we step back, the first level is to have the data. That's what we call telemetry. And the idea is that OpenTelemetry is now an emerging standardized way to get that data. And you might have come across MELT quite often, metrics, events, logs, and traces, which characterize the kind of data you can get from your systems, whether application or what make them run. The technical observability focus is really most of the time focused on debugging-like activities by developers and SREs around your system at hand. So I'm developing something now, I'm deploying something now, and I want to see how it behaves and why, if everything's fine, and then I can move on. Monitoring is a higher level of abstraction, where you're not looking at given transactions one by one, looking at the payload and the time, etc. You're more looking at aggregates, kind of how many booking seats processed were exercised over the past 10 minutes. What was the average response time? Where did the customer come from? What was the average transaction value? And it also covers the alerting use case. Kind of, oh, it used to be a second. Now for the past 2 minutes, it jumped to 5 seconds. Something's changed. And then you can investigate. Have we released something new? Have we changed anything? And help you hone in on the area of change to understand what's different and dig deeper into that. But not only on the technology side, alerting, the monitoring aspects of APM can also cover the use and business aspects. Kind of, is there any change in my users? Are they using different kind of networks, switching from 4G to Wi-Fi or vice versa? Do we have a problem given geographies and not others? It's also about the business. I talked about it a bit. Kind of, since you have the agents within the application exporting technical information, while they're in the app, they can export other stuff, like who's my user? Is it a silver, gold, platinum customer? What's the shopping cart value? What's the ticket price value? And stuff like that. So it's really different. Technical observability tend to be focused on debugging highly dynamic distributed systems for the technical agents, developers, SREs, whereas monitoring is used by other groups for a higher level view of, is my business healthy? If not, where and why? And that technical observability is great, but often needs more higher level abstractions for other groups. So the idea is to collect that data, to group it, like I'm not only looking at one transaction from John buying his airplane ticket, but I'm looking at sets of all the transactions happening over the past minute for everyone buying the tickets. Is that group behaving as expected or differently? And if not, where and why? So on top of that raw data, the idea is to plug AI and ML engines, which are going to do anomaly detection, so kind of learning what normal looks like, detecting when things don't look normal, and then plugging in other engines to say what has changed, where should I look at? Should I look at in the code? Should I look at the configuration? Should I look at my underlying infrastructure as a service? What's different? Where could it come from? To help guide and save time. And that's part of the full domain isolation and obviously the root cause analysis. Since we have information on the use and the business, if you want to at the same time, then it helps you prioritize your actions. For instance, when you come in the morning, you see you have 10 problems. You do your best to tackle them. With AppD, when you come in the morning, you also see you have 10 problems, but you can see that one is impacting the business and you're losing $1 million an hour. 2 are impacting customers who drop out and they have issues. And the 7 others are just technical glitches. Guess which one you should tackle first? Very likely the business impacting one, then the use impacting one, and then the others. So AppD helps break silos because it starts at the application level, but knows about the user, knows about the business impact. Being at the application level, we know a lot because that's where the data is created and consumed. So we know about which ticket, we know about the price, we know about the user, about his email, about his gold, silver, platinum status. So that brings a holistic view of the application, its user, the business impact, and what makes the application run. Because obviously that's one key area of exploration when we try to figure out what's going on. So that's what you can see on the left. Whereas other tools tend to be more siloed. I just look at the network. I just look at the database. I just look at this. I just look at that. And that make problem identification and resolution way harder and longer instead of having that unifying view. So obviously I was talking about the users in the front end. We all know that when application misbehave, when it's a customer facing application, there are consequences. Okay, people drop, people buy less, people unhappy, etc., etc. So what do we do? AppD is not only about the back end. So as you may know, obviously, a lot happened in the front end, whether we're talking mobile apps, whether we're talking web apps or others. There are calls to many third-party services. There's loads of code running, assembling capabilities. Not everything is done in the back end, even though it's a key chunk. So you can deploy, you can instrument your front end and get an understanding of what's happening in the front end and then stitch that back to what's happening in the back end and third-party services to have a complete view. And one way where AIML helps us is when we look at all those traces. Remember when we discussed about OpenTelemetry, one angle is to group them in terms of navigation flow map. So you can see where people start within the application, the next step and the third step, etc., etc. And you can see when people drop, the conversion rates, etc. And you can overlay with that the technical health. So at a quick glance, you can say, okay, people go from step 1 to step 4 to step 5, and then they all drop. And oh, by the way, the response time is 25 seconds instead of 1. No wonder why people are dropping out. You click, and now you enter the technical domain, and you say, okay, why has it gone up to 25 seconds? What has changed? Is it the database that is slower? Is it the network? Is it the application itself? Where does the problem lies into most likely? So at a customers, what we think quite often is these IT war rooms where you have experts in each their domain, database, network, compute, etc., each staring at their screens with their metrics. You have the same kind of situational rooms on the business side of of the house, where people see, conversion rates dropping down, people spending less money, and wondering, why is that happening? Is it linked to technology? Is it linked to our decisions? What the heck is going on? And AppDynamics can help bring those people together, because now you have a clear view about the technology health and performance. You have a clear view on the user and business impact. So you have a common ground to discuss on, compare, contrast, and honing on the most likely area requiring more attention. So many people used to call that biz DevOps, but that's basically the idea. An overall view of my technology health, its use and business impact. Learning what normals look like. When things go wrong, I know most likely where it comes from, the full domain isolation and then root cause analysis, and people and smaller team of people can hone in on that area and restore it quickly. So all of that together is what we call the Cisco AppDynamics full stack observability platform. So if you have a quick look on the left, you can see the telemetry, the data, the melt we discussed, metrics, events, logs, and traces. So it's all the data you can get from OpenTelemetry, from our own agents, from third-party places like cloud platforms, AWS CloudWatch, or others. Then the idea is to bring that into a unified data repository that covers all aspects: security, network, the rest of the infrastructure, compute, storage, your application itself, how it's made of, all the parts talking together, scaling up and down, all the user experience, what's happening on the front end, what does it look like from an end user standpoint, from my interaction on the screen to my response and screen change, to the business impact. Extracting in real time business metrics from your running application so that you can know sooner and clearer what's going on and if and how it relates to the technology health. And all of these informations feed the different teams depending their needs, but if they need to, if they want to, they can browse back to the bigger context of, I've got a server problem, which business transaction was impacted, which customer, etc., to get the priorities right and understand the bigger picture and context. If we zoom in on the business aspect itself, so let's say now you've got your technology monitoring understanding at check, you know what you need to know in near real time, you understand what's going on. Now the next phase is to drive further efficiencies above and beyond AI ML you can find in the technical realm on the business aspects. So the first one is, do I know my business KPIs? Do I know what matters really to the company? What drives the business? Level 2 is, well, can I see them together? And can I get a feel for when my application health goes down, how badly does it impact the business performance or vice versa? The level 3 is an approach where, okay, I'm fixing a technical issue. Can I see in near real time that my business KPI recover and go up again? And then you can progress along that axis. So there are really two domains, the technical domain, and since we have information on the use and the business, you have the business domain. And these use and business domains can help on the technical steps to get your priorities right, focus on what matters the most, observe what matters in short. And then you can also progress on the more purely business aspects of the equation, kind of getting the linkage on the other way around with the technology and trying to automate some of that too, which is kind of future-looking approach. So I'm about 30 minutes, so what some of our customers had to say. So John here from Carhartt, he talks about business IQ, so that business knowledge, business impact. It drives collaboration. Technical people understand that this problem bleeds $1 million an hour, that problem bleeds $1,000 an hour, so which one should I tackle first? And then have educated discussions with the business people on what's the next move and why. Another customer, big airline company, declared that AppD goes above and beyond traditional monitoring. Knowing what matters the most again. Who are the users? How is that positively or negatively changing it? What's their usage pattern? And that brings another level of context and understanding to business people, so they can say, oh, I see, I thought people were doing this, in fact they're doing that, and they're not transacting as much as we hoped, so let me do this, this and that. But they have the context, they see, they understand what's going on to make data-driven decisions, stepping into customer and business shoes. But it's not only about this, it's also about security. So it plays into the same context. As applications tend to become more, microservices based, highly distributed and highly dynamic, the security approaches need to change from, defending at the perimetry, fence, kind of firewalls kind of stuff. If I control everything going in and out, I'm safe. Now that you have your applications in many microservices across your on-prem, private cloud, public clouds, etc., having that overall fence to defend is getting harder to almost impossible. So the idea is to say each and every unit of my application needs to be security aware and defend itself. And by the way, we already have agents everywhere that know of those bits and pieces of your application. They know where they run, they know how they run, and they have full depth into your technical stack and report back information. What if they could also report back some security aspects so that we can detect misbehaviors, fishy things happening in the application? And since we have an agent in place, we can send it orders so that it can act and block stuff to prevent leakage and act on the go and not have to wait for a fix to be released and redeployed again. So you have an immediate mean of action if need be. So thank you. I hope that context helps you from the old times of monolith applications on bare metal servers through to virtualization, microservices, and now the cloud environments leading to the drive for observability. Thank you. Let's move to questions.
Thank you for a great presentation, Erwan. So this is going to take us to the Q&A portion of this event. We'll answer as many questions as we can in about the next 15 minutes or so. We have a few already in the queue that came in during the webinar, but please feel free to continue submitting any others that you can think of. If we run out of time and are not able to get to your question live, we'll reach out offline to ensure that you get the answers that you need. And with that, let's get started.
Hello, thanks. So I'm already seeing some questions coming in. Let's pick them up. The first one I see on my screen is, how do you get business and user information in what you collect? So it's part of the agent. As I explained, they sit in the application, so in more technical term, next to your JVM, next to your .NET CLR, so on and so forth. And they have access to any data flowing through that given piece of the application. So to collect user and business info, we can act many ways. Through the agent, you can go to the SDK, code change, I want to capture this, I don't want to capture that. You can go high level, where the agents report back what it sees, and you have a kind of UI where less technical people not having access to source code can say, well, this is of interest, customer name, that is not of interest, and I want you to collect this, this, and that. So we're exposing things, and you can easily pick up what's useful to you. The other aspect is all on the front end. So once again, we have different kind of instrumentation, but you can grab a lot of data from the front end and the back end, and we report that together with the technical information so that you can drill, correlate, and do all kinds of stuff between the two. The next one is, does AppDynamics detect registry changes from OS related to application? So AppDynamics in itself, no, it's the APM monitoring piece. And when it comes to secure application, I'm not sure. I confess it wasn't designed to be an end user physical device security aspect. It's more designed to be in the back end and to secure all of your microservices, to detect fishy behaviors, unexpected patterns, and to block them if need be. The next question from Arun is, do we have file corruption detection in AppD? Once again, it's not in the add the APM part of it. Maybe in secure app, I'm not sure. We can come back to you that. So the question from Fernando. Please, could you explain how the RASP works with AppD to prevent an attack? So the RASP aspects leverage the agents from a technical standpoint, which now not only report back on the technical health and the user and business data, but they collect additional kind of info. All of that info is sent in raw format kind of the backend on all the detections and the intelligence happens in the backend, and you're presented with a list of problems. And you can say, I want to tackle this one, and then you get a list of actions. And the key difference is that some of the actions can be acted upon as we, on the click, since we have the agents kind of blocking any communication with that stuff and acting on policies, etc. But that part is the RAP piece, runtime application service protection, is what we call the secure application, which is on paper different offering from AppDynamics, which is the monitoring APM part. The next question is AppDynamics like Zipkin and Jaeger. Should I use both? The short answer is yes. Things might change in the future, but for now they serve different purpose. Zipkin and Jaeger are more often than not, mostly, I would say, mostly used by technical people, engineers, SREs, DevOps guys, in more like debug-like experience, where they want to slice and dice all the raw data coming from a service they deployed a few minutes ago, etc. AppDynamics tends to, for now at least, this might change in the future, but for now, the historical focus was more on the IT ops personas, willing to have higher level alerting. Is my overall system healthy? If not, which parts are not healthy? And why in drill down at the higher level? So that's why you have alerting. You don't have in Jaeger and Zipkin. That's why you have some AI/ML engines to help you hone in on the problematic area and why we believe these are problematic. So it's more historically into the monitoring use cases and less into the technical observability, the debugging, slicing and dicing, and understanding in detail. So we can do some of that, but that's just not our historical sweet spot. There are many questions popping out. So the questions from Enrique Perez. What are the data collections requirements for observability? So there are many ways you can go. It's hard to say. So one way is you can use our SDKs. The other way is you can deploy our agents. The third way is you can go OpenTelemetry. We have a public beta now on OpenTelemetry. So if you instrument all of your systems with OpenTelemetry, AppDynamics is OTLP compliant and can consume that. Of course, capabilities will grow over time, but that's the short answer. Feel free to come back and Enrique if you need more detail. A long one from Kenneth. In my career, let me read. It's long. I will summarize it. So the question is, how do you justify cost to management? So what we witness is costs are justified for business critical applications where you bleed money big time when they go down or misbehave. We don't often witness purchase for PTO applications where if they're up, great, if they're down, not a big deal. We're going to reboot, we're going to do stuff, and it's going to be back and running within hours, worst case. So the sweet spot where you can justify cost is really customer-facing or employee-facing, business-critical transactional applications. And that's what our sales guys can help you with. Basically, they come in, they have meetings with you and colleagues, they understand how you work today, how many problems you have, how many war rooms with how many people. And at the end, they help you build a business case saying, okay, today you're doing stuff this way, you're having that many problems, etc. And all of that compound results in a loss of X million dollars a year. With AppD, we believe we can cut it down by 20%, 80%, whatever. and for that amount of money. So our sales methodology, our sales approach, our philosophy at least, is to work hand in hand with you to build a business case of situation today, situation after RAD-D. It does make sense. And you have a business case for your executive and economic buyers. And once again, Kenneth, if you have any questions, come back and I'll try to do my best to answer that. So the questions from Rahul. So what is your observability maturity model based on? So the one I presented was not really an observability, it was a business observability. It was to move above and beyond the technical domain into more of a use and business model, and to try and do things in that realm, kind of getting priorities right and automating some stuff at that level. So it was no longer in the technology domain. How do you see AppD ingesting events, metrics, and logs from CM domain-centric monitoring to benefit the overall observability? Well, our data platform has APIs to get data in and out. As of today, and this will change in the future, you might not be able to fully exploit them with out-of-the-box UIs we provide, but through the APIs, you can get data in and out. And in the future, things will change. Worst case, you can have graphs on your CM data and other data, and you can do kind of visual correlation comparison and see if there's any trends moving in between. But out of the box, obviously, we don't have ready-made AIML for third-party data. We don't know what they want. But it's doable. It's not out of the box. That's what I meant. The next question is your data platform open to ingest and extract custom data? The short answer is yes. But it might need some work to fully leverage it. Because obviously we can't come up with the IML engines, we can't come up with graphical UIs mixing data we don't know of because it's custom data you import into the platform. The next question talks to competition. How are you different from your competitors through Dynatrace? From a high-level standpoint, we follow the same path. And we have a light solution. Where we are different for many years is we pretty early on latched onto the business and user aspect, i.e., I'm telling a basic story. With tools, you see you have 10 problems when you log in the morning. With AppD, you see you have 10 problems, 1 impacting the business, 2 impacting the user, and 7 just being technical stuff with no identifiable user business impact. Which one should you tackle first? So you have all those funnels, so you have all those business views, which are usually really helpful even for technical people, for technologists, as we say, because more often than not, there's just too much, and you cannot tackle all problems. So you need to pick your battle, and knowing which one matters most to the business, the user, etc., is a key difference. Then, of course, there are some differences, but that needs a way longer discussion. But the high-level summary is this, I would say. A question from Martin. Will Cognition Engine be limited to correlation within one application, or will it be able to correlate across multiple applications? It all depends how you define an application, because for AppD, for AppDynamics, you can define the scope as you want. So if you have 200 microservices, if you ask one colleague, they would say, oh, all of them together do one app. And if you ask another one, no. They make up 3 services we call 3 apps. So it's up to you to define the boundaries of what you see fit. And under that lens, we can do multiple applications. So for instance, if for you in the application is the login or the checkout or whatever, and for other people it would be, no, it's the whole ticketing application. So come back, Martin, with more details. You have anything specific in mind? But yes, it can do multiple applications with my short answer. OpenTelemetry is new. What do you support? So AppD for now is OTLP compliant, and we work on traces. If your question is about metrics and logs, as you well know, it's not yet 1.0. We're actively coding against it. but we're not there yet. And OpenTelemetry is not there yet. But we commit to OpenTelemetry. We believe that our core value add is not to generate the data, is to make sense of it and help you focus on what matters. And of course, from a historical standpoint, the bulk of the data was coming from our own agents, and we believe we did a good job. But that's not a rabbit hole discussion. But now that you have a standard way to get data in, which is OpenTelemetry, of course we can ingest it, and we're committed to that because it just makes sense. Martin, fair enough. Okay, welcome. It looks like we're done with the questions. Maybe waiting a few more seconds, and if no one pops in, Alexandra, it looks like we're done on questions so far. Alexandra?
That concludes the QA portion of the event. I want to thank everybody for all your great questions. If you have any other burning things that come up after, you can go to the widget at the bottom and send an email using the Contact Us widget. That'll come right to me, and then I can get it to the correct party and get you an answer. Before we fully close, I just want to quickly remind everybody to check out the resource links that are available in the Resource Center widget on the left side that's right below the Q&A widget. Because once we end the webinar, the screen's going to refresh and it will show the survey. So I recommend clicking through them very quickly just to get those links and save them for future viewing. So with that, on behalf of Erwan, AppDynamics, and myself, I want to thank you for your time today and wish you a great rest of your week.
Bye, everyone.